Just take a look around you for a second. The building you're in, that bridge you drove over this morning, even the sidewalk outside, chances are they're all made of concrete. It's this invisible giant that shapes pretty much our entire modern world. But this super common material, it holds a fascinating secret, one that defines nearly everything we build.
Here's the central puzzle, right? Concrete is one of the strongest materials we have. It's strong enough to hold up skyscrapers. And yet, on its own, it has this critical, almost fatal flaw that makes it surprisingly fragile. So how on earth do we build our world with something so paradoxical? All right, so in this explainer, we're going to break it all down. First up, we'll uncover that hidden weakness. Then, we'll see how a brilliant partnership totally solves it. We'll compare plain concrete to its superpowered version, cover the 3 essential rules for using it right, and finally, we'll give our final verdict on the material that built our world. Okay, let's dive right into that flaw. Think of concrete as a superhero with a very specific vulnerability, like its own kryptonite. It's incredibly powerful, but only when the force is coming from one direction. So concrete's superpower is its immense compressive strength. You can push on it, squeeze it, stack an incredible amount of weight on top of it, and it barely even flinches. This is what makes it absolutely perfect for things like foundations and columns. It is a true champion at resisting being crushed. But here it is, that fatal flaw. The moment you try to pull concrete apart, or even just bend it, it fails spectacularly. This pulling force is called tension, and under tension, concrete is just brittle. It cracks almost instantly. Imagine a simple concrete plank trying to span a small gap. Without any support, it would just snap right in the middle. This weakness makes it pretty much useless on its own for things like floors or bridge decks. So if concrete can't handle being pulled or stretched, how in the world do we build with it? Well, you find it a partner that's strong in exactly the way that concrete is weak. This is where we get to create a real construction superhero. And that perfect partner is steel. Steel reinforcement bars. You've probably heard of them called rebar. They are basically the mirror image of concrete. They have incredible tensile strength. You can pull on them all day long and they just hold firm. So this led to a really simple but absolutely revolutionary idea. What if we just combine the two? And the result is what we call reinforced cement concrete, or RCC. It's a composite material, which just means it's made of 2 different things. You embed the steel bars inside the concrete before it hardens, so the concrete handles all the compression, the pushing forces, while the steel hidden inside handles all the tension, the pulling forces. It's perfect. Each partner covers the other's weakness. They form the perfect team. So what does this team-up actually look like in the real world? How much of a difference does adding a little bit of steel really make? Well, the answer is everything. Just at a glance, the difference is like night and day. Plain cement concrete, or PCC, has 0 steel. It's used for stuff that doesn't really need to bear a major load, like leveling a surface or maybe as a bed for some pipes. But RCC, with its steel core, that's designed for serious structural use. The beams, the columns, the slabs, all the things that actually hold our buildings up. And when you look at the details, the differences are just stark. Check out the tension strength. PCC is super low, while RCC is high. And that single change dramatically boosts its load-carrying capacity from, limited to very high. It's this simple addition of steel that takes concrete from being just a simple filler material to being the primary building block of our entire world. So, if you take just one thing away from this whole comparison, let it be this. PCC is for jobs where there's no stretching or bending involved. RCC is for everything that has to stand up, span a distance, and carry a serious load. One is basically filler, the other is the skeleton. But look, creating this powerful material is only half the battle. To make sure our buildings are actually safe and that they're going to last for generations, using RCC correctly means you have to follow 3 fundamental rules. So, to get it right, engineers follow 3 main rules. First, it has to have strength, enough to resist all the forces acting on it, from its own weight to things like wind and earthquakes. But strength isn't enough. It also needs durability, so it can withstand the test of time against weathering and chemical attacks. And finally, you have to balance those 2 with economy. A design has to be safe and functional without being wasteful. You see, over-designing costs a fortune, but under-designing, well, that's a catastrophe. It's a really critical balancing act. So, with all that in mind, let's wrap this up with a final verdict. We know RCC is the backbone of our world, but like any technology, it's got some incredible advantages and also some pretty significant limitations.
The list of pros is pretty impressive. It's got that critical dual strength against both pushing and pulling forces. It's also incredibly versatile. You can pour it into molds to create almost any shape you can imagine. And on top of all that, it's durable, it's fire resistant, and because the raw materials are everywhere, it's also relatively economical. But, of course, it's not perfect. RCC is extremely heavy, which means the structure has to be strong enough just to support its own massive weight. It also requires skilled labor to get the mix right, place the steel correctly, and cure it properly. If that's not done well, it can shrink and crack. And, anyone who's ever seen a building being demolished knows it's a difficult, super time-consuming process.
Ultimately, though, the impact is just undeniable. By so cleverly combining the compressive strength of concrete with the tensile strength of steel, RCC completely revolutionized construction. It's what allowed us to build taller skyscrapers, span wider rivers, and create infrastructure that's more durable than anything that ever came before it. Really, the world we all see today is in so many ways a testament to this simple yet absolutely brilliant combination of concrete and steel. It solved a fundamental problem and unlocked these incredible new possibilities. Which, it leaves us with a final thought. What's the next revolutionary material that's going to shape the world of tomorrow?